Okay, once more with feeling here. I'm going to I'm going to go over the history of regression and the purpose of regression in this video, and I'm going to demonstrate some of the features of R in going over regression purpose. So, to begin, most people attribute regression to Galton, and I've got it highlighted here. As you can see, Galton in 1885 first mentioned the idea of regression to the mean. So while Francis Galton is an intriguing character historically, he's not really the person who developed regression. Instead, we have to go back to the early 19th century, and specifically to two people, Legendre and Gauss. These two mathematicians, and at the time statistics really wasn't a field, but these two mathematicians were interested in formulating a mathematical procedure for taking many observations and then developing what might serve as the best guess. And that best guess turns out to be, from the procedure you know well, is the mean. But specifically, least squares is the operation to arrive at that best guess. So prior to Legendre and Gauss, there really was no way of taking lots of observations and summarizing them in such a way to arrive at a good prediction for future observations. So these guys, they paved the way for eventually taking multiple observations. So, go back to thinking about a mean. A mean is a collection of observations about a single variable, and if we want to try to extrapolate to observations we haven't made yet, but we're trying to figure out what the best guess would be for future observations, we'd take the mean. But what happens if we take a lot of observations and we think that one set of observations is good at predicting other observations? So, for example, if we consider that collecting data on students' past achievement, academic achievement, and that might be through GPA, and the reason why we want to collect that is we want to be able to forecast or predict how students are going to behave or perform in future settings. Well, prior to the early 19th century, there was really no way of doing this because we didn't have the statistical tools. So least squares form the basis for what will soon be, what is the basis of this course, which is regression. But it really formed the basis for a lot of statistical procedures that we use today, including ANOVA. So everything in the general linear model stems from this early 19th century contribution. And now these guys were trying to solve the problem of astronomical observations. But Galton applied this to growth charts, and he recognized that individuals would deviate. Occasionally an individual would deviate from their historical mean or their familial historical mean, where one person might be taller or shorter than their ancestors, but that subsequent generations would regress to the mean, would differ only in that they may not deviate a whole lot, but the best guess would be this regression, this mean trend. So in future observations, you would expect that the next observation would probably more likely to be the mean. And that's what Francis Galton started talking about in 1885, where he described this regression artifact, or future observations were likely to go to the mean, and that was the birth of regression. So multiple regression and correlation all share their a similar source, where Francis Galton was talking about regression to the mean as a way of predicting future events. And then Ewell and Carl Pearson, extended Galton's ideas and really refined them mathematically to where we are today. So as you can imagine, what regression is regression is both a descriptive procedure, but it's also a predictive procedure. that we're trying to describe what is the underlying relationships between variables or among variables as we go into multiple regression. So the first thing that the purpose of regression is to describe. But then second, and probably more germane to science, is that it's not just to describe, but really to predict. It's to predict future occurrences, and meaning future occurrences are those that have not been observed yet or would likely occur even at the same time or in future observations. So description and prediction, those are the two purposes of regression. And historically, you can see that we're dealing with a statistical procedure. Now we're in 2012, soon to be 2013 at the end of this semester. And right now we're looking at least 200 years where regression has been around, at least from the least squares perspective, and about 125 years or so has been directly applied. So regression is about a 125-year-old concept with tools dating back to about 200 years. Now, what I want to do is I want to take the next few minutes just to describe exactly what regression is, and I'm going to break this into two videos. So I'm going to stop here, and then we'll resume with a second video.